Hey, welcome to The Explainer. If you've ever felt like you're drowning in programming jargon, you are in exactly the right place. Today, we're going to break down one of the biggest, most important ideas in all of Java, classes and objects. And by the end of this, I promise, you'll see how this whole thing is really just about organizing your code in a way that, well, it just makes sense. So let's kick things off with a little puzzle. Think about your phone's contact list. It is the perfect example of a huge programming challenge. I mean, how in the world does an app juggle thousands of different contacts, each one with its own name, number, email, without just turning into a complete chaotic mess? It seems kind of impossible, right?
Well, the secret, it's a really simple but kind of brilliant way of thinking about it. Instead of seeing this giant tangled web of data, the program treats every single contact like its own neat, self-contained little package. And in the programming world, we call that package an object.
Now, here's the really cool part. This whole idea of an object isn't some super abstract techie concept that's hard to grasp. Nope. It's actually something you already get because it's how you see the world every single day. Let's just take a look around. Think about it. Your coffee mug, your keyboard, even your dog, they're all objects, right? Each one has its own features and things it can do. In Java, we just take that same real-world logic and apply it to code. So user account, a button on a website, a product in an online store, yep, they're all objects too. Okay, so how do we actually describe these objects to a computer? Well, it's surprisingly simple. We can break down pretty much any object you can think of into just two key parts, what it knows and what it does. Let's make this super clear with an example. All right, take your smartphone. It knows things, right? It knows its color, its brand, how much storage it has. In programming, we call this data its properties. It also does things. It makes calls, sends texts, takes photos, and we call those actions behaviors. Every single object, whether it's in your hand or in your code, has this exact same knows versus does nature. And that's basically it. That is the big secret behind what an object is. It's just a neat bundle of data, what it knows, and the actions that can work on that data, what it does. It's a way of organizing code that actually mirrors the real world. So let's just connect the dots here. We have our simple ideas, and programming has its own special terms for them. So what an object knows is called its properties, and what an object does is called its behaviors. See, it's really just a matter of learning the lingo. Okay, so we've got a pretty good handle on what an object is. But what about our contacts app? We don't need just one contact, we need thousands. And this, my friend, is where things start to get really interesting. How do we create all of these objects without totally losing our minds? Just imagine trying to make 1,000 contact objects, one by one. For each one, you'd have to remember to add a spot for a name, a number, an email. It would be an absolute nightmare to manage, and you'd for sure make mistakes. There's gotta be a better way. Think about it like building a new neighborhood. You wouldn't just show up and start throwing up houses randomly, would you? Of course not. You'd start with a detailed blueprint that defines exactly how every single house should be built. And in programming, we need that exact same thing for our objects. And that brings us to the second huge concept for today, the solution to our whole scalability problem, that master blueprint for our objects. It's called a class. Now, a class isn't the object itself. That's super important. It's the template. It's the cookie cutter that defines the structure and behavior for all the objects you're going to make from it. It's the set of rules that says, okay, every single contact object must have a name, a number, and an email, and it has to be able to send a text message. And this is where the real magic happens. You design the class just once, and then you can stamp out as many unique objects as you could ever need. It is the ultimate in making your code efficient and reusable. So here it is, our contact class. This is our blueprints. It says that every contact we make is going to have a space for a name and a phone number. Okay, blueprints ready? Let's make our first object. Boom! This is John Doe. We've just created a unique instance of our contact class and filled in his specific information. And now we can use that exact same contact class to create a second, totally separate object. This one's for Jane Smith. See? Same structure, but completely different data. The class makes sure every contact we create is consistent. And why not let's make one more for Alex Ray? With just one class, we've now made 3 unique, perfectly structured objects.
Now you can probably see how this idea can easily scale up to thousands or even millions of contacts.
So we have our blueprint, that's the class. And we know what we want to build, that's the object. But who's the builder? How does our code actually go from being a text file on our screen to a living, breathing object inside the computer's memory?
Well, you can think of it like an assembly line. First, you write the class file. That's your blueprint. Then the Java compiler steps in and acts like quality control, checking your blueprint for any mistakes. Once it gets the green light, it goes to the factory floor, the Java Virtual Machine, or JVM. The JVM is really the heart of Java. It reads your compiled blueprint and actually manufactures the final product, a real object alive and kicking inside your computer's memory.
All right, let's do a super quick recap. An object is the actual thing itself, like the finished house. The class is the blueprint you use to build it. A property is just what the thing knows, and a behavior is what the thing does. If you can just remember these simple ideas, you've pretty much nailed the core of object-oriented programming.
And that's really why this is so important. Learning about classes and objects isn't just about learning some new syntax. It's a totally new way of thinking. You're not just writing a long list of commands anymore. You're actually building a virtual world full of smart, interacting objects.
And that brings us to a final thought. If a class is the blueprint for a standard house, what happens when you decide you need to build a mansion? Do you have to draw up a brand new blueprint from scratch? Or is there a way to maybe reuse your existing blueprint and just build on top of it? We'll dig into that in our next explainer on inheritance.